I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll review the concepts about relations and functions and have 3 questions to test our knowledge on whether a relation is a function or not. So let's try to understand. A relation is a function if and only if for any value of x there is only one value of y. Graph of function is a set of points with no doubling back. Vertical line will intersect the graph of a function at only one point, right? So that is called the vertical line test. So we'll give some examples of functions and not functions. Remember, all are relations, right? To begin with, let's start with an equation. If I write y equals to x squared, that is a function. However, if I write x equals to y squared, that is not a function. Well, the reason is very simple. Since y equals to x squared is a parabola which opens upwards, kind of like this, and x equals to y squared is a parabola which opens sideways, kind of like this. It is not a function. Whenever the graph is given to you, what you need to do is to draw a vertical line. So graph of a function is a set of points with no doubling back. It's not returning back, right? So, and the third point is that the vertical line will intersect the graph of a function at only one point. So if I draw a vertical line, it intersects at one point. Here, it intersects at 2 points. And therefore, it is not a function. Do you see that part? Right. Let's talk about this doubling back. It's kind of like this. On a graph, let us say we have a function which is like a sinusoidal wave, right? So in this case, the wave is moving in one direction. However, if I have a wave which is kind of like this, in that case, this is not a function. You can clearly see that it fails the vertical line test. Right? So, if I draw a vertical line, it crosses at many points. Is that clear to you? So, I hope you have understood the very basic concept. In short, if you find anywhere in the equation something like y squared, then it is not a function, right? So even if I write x equals to y squared is equal to 5, it is not a function. But if in our equation we have x squared, right? So if we have x squared y equals to something, then it will be a function. Does it make sense to you? With this knowledge, let us take few test questions. Here is the question number 1. I'd like you to pause the video, copy this question, work it out, and then look into my suggestions. Question number 1 here is, describe each of the following relations based on the type of mapping, right? Based on the type of mapping. And explain whether it represents a function or not, right? So as far as mapping is concerned, we know there are 4 types of mappings, right? So you can recall that, 4 types of mappings. One to one, one to many, many to one, and many to many. Now let's begin with answering these questions. Question number 1 is, height of a student. Now what kind of relation is this, height of a student? Now you can think like this, that there is a student and that student will have a particular height, correct? So That is the kind of link. Now another student will have something else as his height, but two students can have same height, right? So what we are doing here is we're looking into students and their height. And what we find here is that we have a relation which is one may be mapped to many, right? So this is one to many. Is that clear to you? So height of a student is one to many relation. Now this kind of a relation is definitely a function. Is that clear to you? So we have done part A, height of a student. Now let's look into part B of this question, which is height of a student to teacher relation, right? So we have students here and teachers. Okay. You can make a Venn diagram to explain. So let me make boxes, oval shaped. Okay. Now, a student can be related with many teachers. Since a student may be taking physics, chemistry, maths, something like this, right? Now, a teacher can be related with many students, right? So let's say a maths teacher will have many students in the class. So the relation is kind of like that. Do you see that? So this relation here is many to many relation. And many to many relation is not a function, right? So we'll write down not a function. Clear? So I hope this is absolutely clear. Let's move on and take part C and D now. We are given the ordered pairs to represent the relation this time. The question is, again, describe each of the following relations based on the type of mapping and explain whether it represents a function or not. Now, when you look at it, you see these x values. Mapping is kind of x and y values. So you need to check that x values should not repeat. So in this -1, 0, 1 and 2, they do not repeat. So all x values have unique values. So we say it is a function. That is the first part. Now what type of function it is? We notice that the y values are repeating. That means these two x values are to the same y values, right? So many are related to 1, and therefore we'll call this type of a relation as many to 1. Is that clear to you? You can always draw a mapping diagram to check your result. We'll do that for the second example. Now in the second example, we have 1, 0, 0, 2, 1, 3, 2, 4. So this time I'll prefer to draw a mapping diagram. It becomes simpler. So we are saying 1 is mapped to 0, that's the arrow. 0 is mapped to 2. 1 is mapped to, well, 1 is repeated. So that means 1 is mapped to 0 as well as to 3. And then we have 2 is mapped to 4. So what you see here is that 1 is mapped to 2 and therefore it is not a function. Clear? And many are related to 1. So it is many to 1. Is that clear to you? So once you make a mapping diagram, it is absolutely clear. So whenever you're given in the set builder form, this is also called set builder form. Or in short, set form. So what you notice here is that the x values are repeated. They have different y values. Y values are not unique, right? So since x equals to 1 is associated with 0 and 3, it is not a function. Is that clear to you? Right. So either way, you could say, you can make a mapping diagram, explain as we did, and some many-to-one relation. Many-to-one relation is not a function. Now, we'll do the same. Check for functions using equations. So here are two examples, part E and F. I would like you to pause the video and check it out, and then look into my suggestions. So part E is x squared y equals to 3. In such cases, we need to isolate y. That will be our first step. So we can write here that y equals to 3 over x squared. Now that becomes our function. Y equals to 3 over x squared. If you graph this, what do you get? Well, x cannot be 0. X is always positive. And so what you get here is something like this. Now this graph passes the vertical line test, and therefore this is a function. And it is 1 to 1 function. Perfect. Every value of x is associated with just one value of y uniquely. Well, of course, in the domain, 0 is not included, right? It has a restriction that x is not equal to 0, since the denominator cannot be 0. But otherwise, the domain of the function is all real numbers. We'll talk about domain and range in the next question. Now let's take the next example. So first step is to isolate x, or rather y. So here we'll take x on the other side. So get y squared equals to 1 minus x, and y equals to square root of 1 minus x. Whenever you do square root, you have to do plus and minus. Well, clearly, this is not a function, right? So this is not a function. Since this plus minus means two values, right? So it is a relation which is for one value, we are getting two values for y, right? So if I write a value for x as, let us say, minus 3. So if x is minus 3, in that case, what I get here is plus minus 2. So two y values, right? So it is, actually speaking, one too many. And it is not a function. Is that clear to you, right? So it's a square root kind of a function. I like you to sketch this, right? So we can actually sketch this function also. You can note that the value of x is less than 1, right? And it will be kind of like this, where the x value of 1 will be the x-intercept. Is that clear to you? So for most of the values of x, we'll have two values of y, and a vertical line test will fail. And therefore, it is not a function. Now the last two parts of question number 1, to decide whether it is a function or not and to describe the type of mapping, we have two other conditions. You can always pause and answer this question. G. F of x equals to, it is a piecewise function. Do you see that part? So it is a piecewise function. Now I should write relation. Let's check whether it is a function or not. Now it says f of x is minus x plus 1 for x less than equal to 0, but if it is greater than equal to 0, then it is something else. That means at 0 we could have two values. So what is the value of f of 0? So if you go with the first branch, you get minus 0 plus 1, which is 1. But if you go with the other one, you get 0 minus 1, which is minus 1. And since for 0 we have two values, it is not a function. One value of x can give you many values of y. More than one means many for us. Is that clear to you? So it is not a function and is one-to-many type of a relation. So it is one-to-many relation. Is that clear to you? The last part of this question number 1 is mapping rounded whole numbers to unrounded numbers. What does that mean? Well, let's take an example. For example, if I have the number 2, it can be linked with 2.1, it can be linked with 1.8, it could be linked with 2.4, for example. The number 3, for example, can be linked with 3.0, 3.4, and so on, correct? So what you see here is that we have a relation which is one-to-many. And therefore, it is not a function. Is that clear to you? With this, we end solutions of questions on question number 1. So we now understand what exactly is type of mapping and whether the given condition or the relation represents a function or not. Now let's move on and see question number 2. In question number 2, we'll talk about domain and range. Very critical part of understanding relations and functions. So now we again have 6 parts. I'd like you to pause the video, answer this question, and then look into my suggestions. Let's begin with the very first one, which is f of x equals to x squared. We have seen it many times. However, here we have given two conditions. X belongs to natural numbers and x is less than 10. How will it look like? Let's try to sketch this part. So when I say x is less than 10, there's an equal to, and it's natural numbers. What are natural numbers? Okay, so let's write down here natural numbers means set of numbers like 0, 1, 2, 3, 4? No. Natural numbers do not include 0. Natural numbers is a set of numbers from 1, 2, 3, 4. If you include 0, you're talking about whole numbers, right? So that is kind of important to understand. So practically, we will have to start with 1, and therefore up to 9, the set of numbers which we are talking about are, we will write here like 1 and the square of 1 is 1, right, within the curly brackets. 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square 64, 9 square 81, and 10 square is 100. So what you notice here is that we get only some points, and these points can be represented by dots. So 1 square is 1, then 2 square is 4, then we have 3, 4, kind of like this. Do you see that? So we have these 10 points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, representing these dots. So the diagram or the figure will actually have the dots as shown here, the points Now, what is the domain and what is the range of this particular function? So let's write down the domain and range. Domain for the function is equal to these set of points 1 to 9. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 10 also, right? As far as the range is concerned, the y values are the squares of these numbers, which is 1, 4, 9, 16, 25, 36, 49, 64, 49, 64, 81 and 100. Does make sense to you? So these 10 points, the coordinate x values become the domain and the y values will be the range. And that is how we have to see it. So I hope this concept is clear. The next question here is, let me rewrite clearly, which is g of x equals to 1 over square root of x plus 1. Now the denominator cannot be 0, and since it is within the square root, it has to be greater than 0, right? And therefore, what we do here is we say, well, x plus 1 should be greater than 0. That means x is greater than minus 1. So what we get here is the function whose value for the domain is greater than minus 1. And therefore, for this particular function, we can write that the domain is x belongs to real numbers where x is greater than minus 1. Do you get the idea? How do you get the range of this number? Well, for any value of x, y value has to be positive, right? So the range, the y value, we say y value belongs to real numbers, and when you substitute these values, then what do you get? If I substitute 0 here, I get 1 over 1. Definitely, we will not get 0 for this, right? If x is a very, very large value, you might get 0. If x is 4, you get the value 2. This kind of a graph will be like what? Let me sketch here. Y value is always positive, and it may look like this. So what you notice here is that the y value is greater than 0, and that is the range of this particular function. So we have done part A and B on this page. Let's move on and take up part C. Okay, we'll take part C here itself since I didn't write it there. Okay, in part C, we are given the set of values as coordinate points. How do we write domain and range for this particular function? Now, these values are the x values which form the domain. So we can write the domain of this function as equal to minus 1, 0, 1, 2, and 3. As far as the range is concerned, the y coordinate values will be 0, 2, 2, 1. We can write this as 0, 1, and 2. So if the numbers are repeated, they should not be repeated in your rooster set or the set. Is it okay? So that is how you can write down the range for the given function. So I hope that part is clear. So we did solve C also on this page. Let's take up D now in the next page. Question number 2, part D. Find domain and range of each of the following. X, y equals to 1. So first rewrite what y is equal to. Y is 1 over x. So it is kind of a reciprocal function, which is, if you graph, x could have all the values except 0. So it is a function which is like this. Now in this function, clearly, we know that x values, the domain, will be what? X belongs to real numbers where x is not equal to 0. And as far as the range is concerned, the y values also belong to real numbers, but y value cannot be equal to 0. Since x equals to 0 gives you an undefined term. So we have a vertical asymptote at x equals to 0 as shown in this particular diagram. Is that clear to you? The next part here is x squared plus y squared minus 16 equals to 0, where y is greater than equal to 0. Okay, let's first rearrange. So we get y squared equals to x squared plus 16, and we get y equals to plus minus square root of x squared plus 16. So we get that kind of a graph. Now definitely if we have plus and minus, in that case we are looking for something which is having two values, so it is definitely not a function. So it is a relation for sure, right? Now we have to figure out the domain and range. Now in this relation, it is x squared plus 16, not minus 16. Okay, so you will notice that x, let me write domain x, right? So you notice that x belongs to real numbers. X can have any value, no restrictions, right? Because x squared plus 16 is always greater than 0, right? It cannot be 0. Now let's talk about the range of this function. So y belongs to real numbers. However, y could be anything, positive or negative, right? So what are the values of y which we could have? If x is 0, we get square root of 16, which is plus minus 4. So let's try to think about it. So for 0x, we get plus and minus 4. For a value 1, we get something which is more than 4, right? Which is more than 4. Let's take 3 for example. So if I write 3, we get plus minus 5. So what we notice here is that this value is never in between plus and minus 4. So for this particular function, this is a test question. The range will be that the y value is either less than equal to minus 4 or y value is greater than equal to 4. Does it make sense to you? Right? Since for any x value, we'll get something which is either 0 or more than 0. And therefore, plus minus 4 becomes the minimum value for this particular relation. So I hope that makes sense. So make a note of this question. It is a very important test question. You notice that the y value is not including something in between plus and minus 4, right? Now let's take the next question, which is a piecewise function. So once again, let's treat a piecewise function. For some students, piecewise functions are really tricky. And it is indeed, right? It is different from last time. It looks similar. Find domain and range of the given of each of the following. G. F of x is minus x equals plus 1 when x is less than 0 and is equal to x minus 1 for x greater than equal to 0. Earlier, we had less than equal to, which was not a function. Now it is different. Do you get it? So at 0, what is the value of the function? So if I write f of 0, then we are looking into the second branch and the value will be minus 1. Do you see that? And if I write f of 1, we are again looking into the second branch, which is greater than equal to 0. So we get 0. And f of 2 will be 2 minus 1, which is 1, and so on. However, if I have a value which is less than 0, let's say minus 1, then we have to substitute minus 1 in the first leg. And here, minus 1 will make it positive 1. 1 plus 1 is 2. And f of minus 2 will be 3 for us. Do you see that part? Similarly, f of minus 3 will be 4. And if you want to sketch it, at 0 the value is minus 1, and then it is increasing, right? So it is increasing thereafter as the value of x is increasing. So from minus 1 it is going like this. The point here is minus 1. For the other half, when x is minus 1, the value of the function is 2, and then it is increasing. Correct? Now, if it is not 0 but very close to 0, it will be at plus 1. So at plus 1 we have a whole not considered to be part of this function. It is going to be something like this. Do you understand? So that is the y value or f of x, and this is the x value. Here is your origin. This value here, it approaches 1, but it is not quite there. So if you are negative, slight, like 0.9, but with the negative sign, you are approaching 1, but you are not quite there. You understand? 0.001 minus will be 1.001. So now we can write down the domain range for this particular function. So clearly we have a domain of all real values. So domain of this function is x belongs to real numbers. As far as the range is concerned, you clearly see that the y values belong to real number. However, they are always greater than equal to minus 1. Does it make sense to you? Right? Excellent question. So let's move on and see the last part of our video. Here we'll evaluate the value of the function using function notation, right? So this is based on function notation. The question here is, a function is defined as f of x equals to x squared minus 6x. Write down the range of the given function. So how do you find range of the function? The function is f of x equals to x squared minus 6x. You may have to sketch it. You may do completing the squares. You may, somehow you have to find how to get the range of the function, right? So one way, of course, is that we'll try to sketch this. We can write this function as equal to x common x minus 3. That means it has two zeros. One zero is at 0, the other one is at 3. Definitely somewhere in between, at 1.5, we'll have a vertex. And this parabola opens upwards, right, from our previous knowledge of parabolas or quadratic function. So it is something like this. We have to find this value. How do we figure this out? Well, you can always find the value of the function at midway between these two, which is 1.5, and that will give you the lowest value. This is one method. The other one is to complete squares. So we could write this value of f of x as equal to, so to complete the squares, we have to add and subtract. Half of 6 is 3, and then we can figure it out. So when you do that, we can do x minus 3 whole square, and that is minus 9. And that gives you minus 9 as this value, the lowest value. The vertex is at 3 minus 9. So we can say that for this given function, domain is x belongs to real numbers. However, the range is y belongs to real numbers, where y is greater than or equal to minus 9. So you could adopt any of these methods If you find the value f of 1.5, you'll get minus 9. So that confirms that the minimum value for this function is minus 9, and therefore the range should be greater than or equal to minus 9. Perfect. So that was the most difficult part of this question. I'd like you to pause the video and answer the other two. Let's figure out what is the value of f of 2 plus 5. So to find the value of f of 2 plus 5, we'll actually substitute 2 here. So we get 2 square minus 6 times 2 plus 5. And that is 4 minus 12 plus 5. And that is equal to 9 minus 12, which is minus 3. Minus 3. So the value of f of 2 plus 5 is equal to minus 3. Is that clear to you? Right? So just substitute and get your answer. Now, let's look into the next part, which is find f of x. If f of x is minus 5, find x. So let's figure this out. So we are given minus 5 for f of x. We'll write this as minus 5 equal to x square minus 6x. 0 equals to x square minus 6x plus 5. Now that could be written in the factored form. 5 times 1, both negative, will give you plus 5. So I could write this as x minus 5 times x minus 1. Now this will be 0 for x equals to 5 and x equals to 1, correct? So we get the value of x as equal to 1 or 5. Does make sense to you? So that is your thinking question. Let's say tips. Slightly difficult at this stage. But I hope you'll have to recall what you learned about quadratic functions while moving forward with this advanced level course. So truly speaking, this is a level A part of the relations and functions, and you should be thorough with quadratic functions which you have already studied earlier in grade 10 and in grade 11. I hope that makes sense. With that, we come to an end of our questions based on functions and relations. I hope you find it interesting and useful. Feel free to write your comment, share your views. Also, look into many other test practice questions and then move forward to the next unit. Thanks for your time and all the best.